So, welcome to this last and final talk. For today, it's going to be about saving CO2 and maybe there are other reasons for you to improve performance of SMW than this, but in any case, this could be among them. Well, I mean, there are probably, but let me check one thing first. Do we have a camera running? Ah, okay, so all my setup is recorded as well, very good.
Yes.
Let's upload this. Okay, so why care? I mean, one thing, of course, is like it happens to me sometimes, that the world's largest hoster of wiki sites sends you an email with the subject line, Semantic MediaWiki has brought down our servers again. Which obviously is something that you want to avoid. So if this is happening to you, or if you have customers who think that this is happening to them, then it's useful to be aware of performance issues. There are other less critical but still severe issues when people actually come to you and complain and say the site is running too slow. This is something you cannot normally afford if you want to run a successful site. Speed responsivity is very, very important. There have been user studies showing that people associate the quality of a service on the web very much with the responsiveness, irrespective of what it actually gives them. If it's fast, they will be happy. Then even if this is not, even if they don't come to you, the tautological thing, which everybody always says, is our site could speed up a bit. I mean, no site is as fast as it could be. And then, well, there's also an economical issue. We might want to less hardware energy, and maybe also want to save some energy indeed for the environment. There are many, many reasons, and I guess everybody who runs a wiki or is involved in running one, even as a user, has some interest in improving performance. So why am I giving this talk? Does it mean that Semantic MediaWiki slows down the servers in such a big way that it's actually relevant? I wouldn't say so, no. Rarely directly, at least. Surprisingly rarely directly. So Semantic MediaWiki is not quite as heavyweight as it's sometimes thought. But what it does is often suggesting usage patterns that stress already the underlying MediaWiki quite a lot, and where optimization is important to get things running fast, because it introduces some usages which are not typical for the MediaWiki software, or which push it quite a bit to keep up with the demands. So let me start at step 0 here for optimizing Semantic MediaWiki. Configure MediaWiki properly. This is in many cases, first of all, that's something you should always do, whether you have a performance problem or not. And secondly, in many cases, it can solve quite some parts of your performance problem without looking into any particular details of your application. Well, reasons are obviously that MediaWiki does most of the work, even if Semantic MediaWiki is an important extension and is the basis for many other things. Most of the work, and including most of the page viewing and displaying work, is still done by MediaWiki, and it has to be optimized. And there are a lot of hints online to optimize MediaWiki, so it isn't there is not really any reason for not doing it. And do it first, so you see whether it already helps. Now, one thing you will all have heard of to some extent, and maybe some of you know all of this, is that there are an arbitrary number of caching layers available for MediaWiki to make things perform better, faster, and basically to avoid repeated work. So I'm not sure. I mean, let me maybe first do a quick poll. Who here is administering on the server side a MediaWiki? So there are quite a few. So then I'm not going to skip that too much, but I'm going to go through it quickly anyway, because I think much of it is documented online and we are running out of time. So there are basically 3 different things that you can cache. First is bytecode, PHP. Second, object in PHP, and then there's a page cache. I'm going to explain them in short. Bytecode. Well, basically, PHP is a script language, so what happens if you don't enable anything in the default installation is that every time somebody accesses your wiki, the PHP pages will be parsed, interpreted, and run as a program. And so what you do is you have a static PHP code, which doesn't normally change a lot, but which you interpret again and again, and which is very slow, obviously, because it is not compiled. What you would like to do is like to pre-compile it. And this is what bytecode caches basically do. Say, make the PHP ready for fast execution instead of doing it from text every time somebody clicks on your website. Which is quite obvious, something that you want to do and everybody wants to do. But on the other hand, it's surprisingly rare. I mean, among small sites, if you talk to people, many are still surprised that there is something like that and how much it can speed up their site. So be aware of this. And it's possibly the most important thing to increase the responsiveness of a small site, I would say. Because it really makes things feel much faster. You can really see it through the interface that your web pages will appear quicker after you do it. And the nice thing is it's quite trivial to do. All you have to do is install some bytecode caching module for your PHP if it's not there already. All the PHP distributions will have some, all the other options for you available. If you run Debian, for example, it's as simple as typing this into your command line and pressing enter. In other distributions and operating systems, you might have other things, but in the end, it boils down to something very simple most of the time, I think. And that's all. It's automatically faster. You don't have to configure anything. It's just there, right? And so there's really no excuse for not having this done. Object caching. This is a bit more advanced. Object caching. The idea with object caching is that you store objects or values which are relevant during PHP program execution in a cache, so you can use it again and again instead of, for example, retrieving it from the database each time somebody wants it. So, for example, user settings or some other commonly used things which you use again and again. Keep them in between sessions, because basically every time somebody clicks on your application, it's a new session, and you will lose all the in-memory values you have constructed if you don't have some consistency by such a cache. Again, it's quite trivial to enable this. If you have installed APC or some other similar caching system for bytecode, it usually has a feature for that, and all you have to do is to add to your configuration such a simple line saying that the main cache type, meaning the main object cache type, is this constant. And then automatically MediaWiki will use it, and it will be faster. So again, no excuse for not doing it. Large sites with many application servers cannot do that. They need something distributed and will want to use memcached. Sites with untrusted servers where many people can log in may also not want to use it because these caches are accessible on the whole server, so maybe it's not safe to have sensitive data set. But then maybe you shouldn't have a shared server which you don't trust in the first place if you have sensitive data. Okay. So this is object caching, and there are special cases of object caching that are of particular interest. One is parser caching. The parser cache is something that many people have heard of because it has some relevance also when you work with MediaWiki as a user. You will come across it from time to time. The idea there is that the object that you're caching is the output that you get after parsing the text of a wiki page. And it's not yet the HTML, it's not yet the text. It's some intermediate representation that MediaWiki uses to create the final page. And this parser cache, as it's called, is very useful to speed up the page rendering process because you don't have to parse everything from scratch. But its lifetime is actually by default very short, just 24 hours. So if you have a small site and your wiki pages are not accessed very frequently, then in 24 hours you are likely to not have any hits on this cache unless somebody views the same page again and again, which might happen. I mean, you don't know, but it doesn't really have a big positive effect on you. And on such a small low traffic site, you could possibly want to change its configuration so that the cache lasts longer. This would be 30 days, for example, and maybe you also want to put it into the database, which is something which you can have with such a setting, instead of storing it in some other place. By default, I think it's stored in the file system. I think it's not disabled. I think it's by default used somewhere. Okay, that's for low traffic sites, but that's a place where the default is maybe not the best if you run such a small site as many of us do. The problem with this cache and with other caches as well, but increasingly with this and later caches I'm going to show, is that caches are cleared only in some situations. In particular, in this case, where on edits but not on indirect changes. So for example, if the result of some ask query changes, you will not see an update if your parser cache lives for 30 days. And so this is a trade-off you have to consider, and we don't have a method yet to invalidate caches intelligently and on demand. So for ask, it's quite non-trivial to do that. And supported ideas are welcome, but so far you have to kind of balance this. And you know that there's this little refresh tab on the top of each Semantic MediaWiki page, which forces the caches to be all cleared, and which allow you to make sure that you see the most recent result. Okay. Another thing which is important, very briefly, is message caching. Is also a type of object caching which caches the interface messages, the things which have which are translated to make a user interface. And here is the main thing to note is that you want to set, if you have, especially if you have an older installation of MediaWiki where the local settings file is inherited from past generations, then you might want to make sure that this variable here sets the cache directory, which provides a space, a file space where MediaWiki can cache data in. And this is, if it's not that, it can't do that. And this is actually helping it a lot to speed up message rendering. So it's going to, again, make a big difference, and all you need to have for this is a directory which the web browser can read and server can read in the browser, hopefully not. Now again, it's very easy to do, but it's not necessarily active on your site. You can check it. Okay, and then, well, the last things I want to say about caching, and then I'm through with that. File caching, of course, the obvious thing to expect. You just store what the user will see in the end. It's less powerful than one may think, because if you're logged in as a MediaWiki user, you will get your own name appearing somewhere on the page, and you will have customizations on the layout, maybe depending on your skin settings or something like that. So the HTML is actually different for every user. So if many people on your site are logged in, then this caching is not necessarily helping you. But for all the anonymous views and all the crawlers, it makes a lot of sense to just store the HTML page. So maybe you can even provide some things without having any database lookup at any kind of computation. You just give us a file. And to enable this, you have to, again, set up some configuration. In particular, you have to make sure that the pages are not personalized in any way. For anonymous users, so they shouldn't get an anonymous user talk page link, for example, for their IP address or something like that. And, well, you can compress these files. Again, since it's a very aggressive form of caching, it just means that all the previously produced files are going to end up in some directory, and they are going to come straight from there. Can really push down the load on your server quite a lot, but it also, again, introduces the same issues with freshness of the data as before. Because you can get the old cached versions if something indirect changes. It's not just ask, it's also something like parser functions that give you the current date, for example. They just show the date, of course, of what has been the case when this cache was created. Well, and for more advanced users, file caching is really the most basic way of doing this kind of output caching, which everybody can do without installing any tool. But if you have a more advanced site, you want to use something like Squid or Varnish, some kind of HTTP level cache. Maybe also your web server has some feature for that. I'm not going to look into that here. Okay. But, so, I mean, everything seems to be fine, right? We have a lot of caches on all levels. We can cache we can cache the PHP code, we can cache the PHP objects, all intermediate results that we actually need to come up with a final parsed page, and then we can cache the final parsed page and get this without even doing any computation for many people. So it seems all good, right? The problem is, even if you have an ideal setup with caches, and even if you really invest a lot of time into that, you're not going to completely bypass the issue of computation time per page. There was a famous Michael Jackson incident on Wikipedia, where due to the death of Michael Jackson, Wikipedia was brought down, which was quite surprising for many people, including the administrators of Wikipedia, because it was at this time already a very developed and complex and very stable and robust architecture. But the problem which occurred there basically was that very many people requested the same site, the same page, the same article in a very short time. Shouldn't be a problem. You have all these distributed caches, right, server farms worldwide. But unfortunately, due to edits, recent changes, on the page due to recent activity in the subject, this page needed to be updated, and it was a very long page, so it had to be reparsed and recreated at some point. This takes some time. For a very large page, it can take tens of seconds, half a minute. And in this short time of half a minute, you get a lot of new hits. Again, they all will find an empty cache. So each of these new hits starts to run a new process, which also will start to reparse the whole page, which still takes about 30 seconds. If there weren't already millions of processes doing the same thing on the same server in the background, which essentially leads to a situation where the cache is never going to get filled because even the first process is not going to terminate because everybody is recomputing and nobody finds a full cache. Obviously there's some stupidity going on here and this should be prevented, but it's not so easy and it can easily occur on smaller sites as well. We've had that in KIT. Some of the early problems where we launched our site was that people, just for trying it out, were clicking refresh a lot on their pages and were creating this phenomenon all by themselves, more or less. So it all depends. And it's really a matter of how long your refreshing takes. If it's 10 seconds, the chances are pretty low that this is going to happen up to a certain traffic. If it's 60 seconds, it's quite possible that somebody managed to trash the site like that. Okay, so that's why caching alone is not solving all problems and we need to do something. And then, of course, the other thing is that, especially with Semantic MediaWiki, you want up-to-date results, and caching can actually reduce the quality, and you may not want to have very long cache periods. And so to refresh it more often is actually good. Okay, so we want to be fast. There are other ways to make things faster. I'm not going to go into this. This is also intended to be read offline if you want to look it up. So the slides will be online and you can have a check on this. There are some settings. There's also something you can do about the job processing in MediaWiki, which might help on a larger site. Okay, now what can we really do about Semantic MediaWiki? First of all, to start optimizing in a concrete way, we have to know our problem, obviously. This is actually a very difficult part, maybe the most difficult part of all, to really find out what your problem is. Many questions have to be asked here. Where does the problem occur? Is your processor running hot and melting, or is your memory running out? Is your database not coming back? What exactly is happening and why? Then when does this occur? Is that a particular function that has been triggered, or is it just that there's high traffic in some time of the day, or are you under a denial of service attack? Maybe some crawler misbehaves, something like that. And then if you know this, an important question, of course, will be which software components are actually involved. Is it Semantic MediaWiki? Is it just MediaWiki? Is it some extension, maybe some extension of Semantic MediaWiki? This is all not so easy to identify in practice because many of these things use similar functions and can indirectly cause the other component to use much more time than expected, and it's sometimes very hard to track it down. But I encourage everybody who has performance problems to really take a lot of time for this step. We've had situations in the past where we spent a lot of time optimizing one software component to find out then later on that the company actually didn't have a problem with this component at all and rather would like to optimize another software component instead. So that's, of course, it's better if you know upfront what your problem consists of. Okay, so what can you do? Suggestions I can make here are obviously just very generic because it really depends on your setup. But basically there are two levels. One is on the server level. You can look at which process does the work, which process and which resource is consumed here. Helpful, there are all kinds of log files that you find on the server, Apache logs, access rates and stuff. You can often see whether there's an impolite crawler. Maybe some properly configured robot texts will already help you a lot. MySQL has logging facilities. You can have a special log for slow queries, which is quite helpful if you think your database is under too much stress. And then in the end, there's also MediaWiki profiling, which basically just means that all the functions in the code get tracked and timed, and you can look at these times from the outside. Which is quite an advanced mode of profiling for people who don't know the code, because you will just see function names, and it's not necessarily clear what that means if you are not familiar. So wouldn't generally suggest that. Also, one should keep in mind that profiling and logging takes a lot of time. Even this MySQL logging, or maybe also Apache logging, I'm not sure how bad this is, but any log activity is activity and will take time. And the more you log and the more you profile, the slower the site will actually get. So switch it off once you're done with it. Yeah.
Does SMW contain any MediaWiki log profiling statements?
Oh yes, so quite a few, yeah. So if you enable the profiling, you will also see a lot of Semantic MediaWiki output. Yeah. Also, the Semantic MediaWiki, the MediaWiki log includes all queries and abstract versions of the SQL queries, so you can also see all the SQL queries and can maybe make something out of it and see whether it's Semantic MediaWiki causing it.
I guess you might know about this. There's a small command line script that can analyze the MySQL configuration and give a lot of hints. So
yeah, I mean, you mean to concretely optimize MySQL performance?
Yeah.
Yeah.
I don't remember the name. I use it all the time. So.
Yeah, obviously the whole issue of optimizing is a very broad one, and I'm trying to focus and get the Semantic MediaWiki part here. But it's completely true that if you just want to optimize MediaWiki in general, you will find an awful amount of MediaWiki and MySQL in particular. You will find an awful amount of resources on the web how to do that on a web server configuration in general, whether you run MediaWiki or not, and all of this can of course be useful. Okay. The other aspect, besides this merely technical way of finding the problem, is actually to look at your community and your users. And this is something that also users can do if they find that their site is too slow, or that the page builds too slowly, or even blanks in some cases. You have to know your wiki for that and know your users, and know what are the complex templates and queries in your wiki and which pages normally cause problems. And maybe this is even the more useful approach in some cases, but it's again difficult for the administrator, because as an administrator you often don't have this insight into all the content of your wiki.
How much intelligence is there if page 1 uses a template and computes something from one page, and page 2 uses others from that, and you've got cycles going?
Well, cycles of templates shouldn't happen, because they are.
I'm pulling properties from 2 places. You'll see it tomorrow, and it's a very much intended behavior. But I'm not sure. It seems to still work fine. But I know I'm pushing performance concerns. So.
No, I mean, what I mean is inclusion cycles shouldn't happen, because otherwise it would become infinite. But yes, I mean, not sure what the question aims at. I mean, the point is it's difficult to find the exact page where the cause is. Is that the...
No, it's... Is there anything in the design of Semantic MediaWiki that makes having 2 pages each pull properties from the other, and therefore an update in one triggers an update in the second, which triggers an update in the first, and does that eventually balance down pretty smartly, or does it potentially just alternate back and forth forever?
Oh yeah, it might run forever, yeah.
That's good to know.
One...
Seems okay so
off topic for this talk, but using query results as annotation values to store them back into the database and change query results again gives you a Turing complete mechanism combined with if and then. And so that's very, very nice, and you will never know whether it converges and to what. So any computation can be implemented by refreshing pages again and again.
Correct me if I'm wrong, but I don't think that ask query results ever trigger new jobs. Only the changing of templates would do that, and we don't do that here. So they would run forever if they would trigger those jobs, but they actually don't do that. So the pages are not stable, so the content will get, whenever it gets rendered, it will get changed and so on. But they don't create new jobs, and therefore this does not happen.
Yeah, that's true. It doesn't happen automatically. It's like a Turing machine where you have to trigger each step again to a more efficient way to do that computation. So what would you normally expect if really Semantic MediaWiki is your problem? What are the typical things? Well, there are many small database reads. For example, finding the default form. If you click on a page, it will check whether there is a default form for it. It will trigger a database access with semantic forms. Also, Semantic MediaWiki does a lot of queries to just find out the ID of some page, some internal IDs, stuff like that. So you will get a lot of small queries. You will also get a lot of rather small writes, because every time somebody edits any page, it will write semantic data, whether it has changed or not. This is a bit of a weakness which we want to address in the future, but at the moment this is what happens. So a lot of writings going on to tables, usually very small amounts of data. On the other hand, there can be very complex queries. If somebody has very large queries, it might be one complex read, which happens and which takes a long time. You can see that in your slow query log. And then on the other hand, you have sometimes very long complex pages, which isn't that really a fault of Semantic MediaWiki, but it just makes it easy to create them. You make one ask query with a fancy format, you say limit is set to 100, and you get many screens filled with nice formatting. That really will take quite a lot of time to parse in MediaWiki. And then there can be very complex templates. Again, this is not really a Semantic MediaWiki issue, but it turns out Semantic MediaWiki users also love templates, and they really like to combine parser functions, templates, and queries in a most innovative and interesting fashion. That's not necessarily good for performance. So two main areas are here. One is database activity, one is PHP activity. So the lower two is mainly PHP and CPU load, maybe also memory issues, and the upper one is mainly database issues. If you have a bit of a larger wiki, these will be on two separate servers for you. In a small wiki, PHP activity dominates by far. So you will normally not have a MySQL issue, but normally you will have a PHP issue if you find your slide is too slow. Okay, so first thing, and I think maybe the most pressing one, is optimizing by doing something about these templates. I know it's tempting, it's so great to have this data management system. You can do all kinds of interesting computations on your pages, build things dynamically, adaptively for the current situation and context of the user, whatever. And all with templates, right? But that's maybe not what was originally intended. I mean, originally templates were meant in MediaWiki to reuse common parts of a page for consistent layout, customized with some parameters. And parser functions enable some further customization, so some small switches in whether this should be green or red in this table, for example. What users make of it, on the other hand, is some kind of in-page data processing in an extremely inefficient and unreadable script language. And I'm not talking about PHP here. Even less efficient and even less readable. And well, with SMW somehow this all becomes more entertaining and engaging, and people really spend a lot of time doing it. Here's a nice example. This is a simple page. You can see some sentences, some table, info box-like. You can imagine how this looks in source code, right? You would think so, right? But if you look at if you look at the page and you edit it, you see this. This is the top of the page. So you would wonder, where's the text? Where's this all coming from? Normally, I mean, okay, here's biography, but that's what we saw here. But then, what's that? It turned out that's show facts biography, a template, without a parameter. It's just sitting on that page and it makes the text. Now let's look at this template. This is what I mean with template hell. We are kind of getting there. So this template is only halfway down to the bottom of template hell, really. Because if you look at it, it has some text. Mostly here's this HTML comment. I'm not quite sure where all the actual text is coming from. I couldn't get down to this. But there are a lot of show fact template calls here. Show fact. Now let's look at show fact. I mean, you see there are many facts shown here. Show fact now is this. Again, this is not too easy to read, but at the center it triggers some show, which is a parser function of SMW to create a query based on the current page name and some other things. I'm not completely sure about everything here, but it's hard to say anything about this. But okay, so the problem we have obviously is that here a whole page with all its text and all possible texts that could be on any page of a similar kind is generically built out of a simple parameterless template call just by looking up the database many times. And you can, the database lookups here are not just database lookups for actually producing some fact, like text output, but also database lookups to check if something has to be produced. And this happens independently in different template calls. It might not even be cached in all cases. In effect, this gives you an incredible amount of template to parse. I mean, this was just the first template. This doesn't explain yet where the info box comes from. And what I didn't find out today is where the actual data is. It's quite unclear to me. I mean, the page about this person doesn't seem to contain the data about the person. It's just like miraculously appearing from the cloud somehow. Okay. So this can easily take more than 1 minute to render such a page. It has many database reads. Any guesses how many reads there should be? I know Danny knows it. How many reads do you think individual database queries that get triggered for producing this page?
50.
50, okay. Do I hear more? I hear 50. Yeah, okay, it's just 2 orders of magnitude off, so it's 3,000. I'm not quite sure why. I have the query log. I can see them. They are mostly unique. I think some repeat, but most of them are unique.
But each show has one query.
Yeah.
Doesn't this explain it? I mean, you had a number of shows in each of the shows.
Yeah, but not 3,000.
But you had, let's say, 20 shows in each show fact. Then we had around 100 show facts.
Yeah, maybe. I mean, okay.
It is geometric.
Also, if you look at the queries, many things that are queried there don't actually appear to have anything to do with the page. And maybe this is because of jobs, but I don't think so, because we had this on a separate testing server where the log came from. It wasn't on the C production server. Anyway, this is not good. We need to do something about that. And so what can we do? What could the solution look like? Well, all these reads really need it, and I would like to make a distinction here between good and bad queries. Good and necessary, and really the idea of the SMW are global queries. So you want to aggregate data from many pages. Show me all upcoming events, how many cities are in my wiki. These are queries that you cannot possibly answer on a single page. You have to do queries to get this information. Also, global questions. What is the largest city? Is something that changes. You have to look at the whole database. That's what the power of SMW comes from. On the other hand, quite bad is that people also use it a lot. I mean, I understand, I have done the same and I'm doing the same in some cases. For local formatting, what you do is you fetch and process data from a single source, with show in particular. I don't know why we even introduced this.
This was me.
Oh, you introduced it, okay. Okay. So from a single source, which you already know when you write the article, basically. You already know what the source will be. And then you do a complex result formatting with it using format template, which blows up the whole parsing process and makes it very slow. This is bad because it's avoidable, because we have all the data is local, and basically we already know what has to be said on that page. But instead of just saying it, we query it again and again. From the database, as if it could have changed somehow. Also, in this case, in this example I gave you, I'm not even sure where the data is, so maybe it could have changed. It's not so clear. But normally, if your data just comes from one page and it doesn't change without the page being changed, then you don't have to get the data from the database. And one solution for this was done in the KRT portal, because it turned out that there a very similar problem occurred. We needed very complex formatting, namely for publication entries. So the page looks like this. You have things which are published, and they have a complex formatting. You can have a large amount of authors which you don't know in advance. You have some link and some name of the publication, and you have publication details, including the page numbers, stuff like that. It's all separate data, and it has to be assembled into one thing. And doing this with a template is tempting and works, but if you have people with hundreds of publications, then this is going to be very slow. And so the idea that was realized to make this faster, which really worked very well, was to exploit the fact that we already know this data when the source is edited. So if somebody makes a new page for this publication, for example, then it's already clear how this should look in formatting, right? It's not changing anywhere from any other information, it's local. So we don't need to rebuild this in all query pages. I mean, the exact same representation of this thing is going to appear in many places. So let's cache it. We just store the complete pre-formatted output string on the source page with a property of type text. So we store it as a text block, and then simply recall this in all the queries that use this thing.
So we build yet another caching level with Semantic MediaWiki?
Yes, exactly. So we do caching inside Semantic MediaWiki indeed. The advantage is we get pre-expanded wiki text, no templates in this anymore. I mean, it might be complex to construct, but it's only constructed once when you edit the source of the data, and not every time you use it somewhere. No templates in this output, no show, no parser functions. Much easier for MediaWiki to handle as well, even if the page is long.
Doesn't it go against an IT thing that you store the data already in the presentation format?
So, I mean, on this particular server, the server died with as little as 10 users.
It's just like a quick fix for that.
Well, I mean, the thing is, it's very controlled. It's not a hack that just happens and that can have good and bad results. It's something that you use in a very conscious way to solve a particular problem. And the nice thing is, well, it gives you full control on the user level. To make a page very fast. Because the user is in the end the person who controls how this is going to look and how this is going to be cached. Essentially, as Danny already remarked, it's a user-controlled database-based parser cache for snippets used elsewhere. So it's like your own sub-parser cache. And of course, yes, it introduces some redundancy in the Semantic MediaWiki database because you store things literally which you already could construct from the rest. But there's no reason why the SMW database should be non-redundant. As long as your pages are, you can make sure that on the pages the data still appears only once. With the variable extension, for example, or just by templates, it is easy to make sure that the title of a publication is entered only in one place and not twice, even if you want to cache it. That's a useful thing. It is, unfortunately, in comparison to the earlier things I showed you, this year will require some work. You have to know the wiki, you have to know how these things work. I showed you an example where nobody does know this, I guess, and where it will be very difficult to implement this because you really have to dig into this huge template and find out what it does. And also, it's harder to apply if the formatting includes non-local information, obviously, then it doesn't really work. You have to, as long as you just format something which is on one page, it's nice. But if the format already includes information from other pages, then storing it in a database string will introduce a never-expanding, outdating cache, which is not going to be refreshed ever. The thing is, even if you refresh the view of a page, it is not going to refresh the data. It's not going to restore it in the database. So if you do this method, you should do it only with local data, which is local to the page. Then you have a perfect updating cache, which perfectly updates whenever needed, which is very nice. On the other hand, if you use any data which is not local, it's the opposite. You will have a cache which never updates, even if needed.
Do I understand that the data items are on this page and that you create the string by querying that data on the page? So you do not write the complete string?
No.
Okay.
This is, I think you understand correctly. In the particular case of the AFB portal that I showed you, the string is not entered by a user, but rather there's a template where you enter the information and from the template parameters it's constructed. Okay. It's a bit more complicated because in the AFB case you have something like an arbitrary amount of authors, which by design of semantic forms all end up in separate parallel templates. So you have many template calls, And there's no way to get all this information into one place, but you can use the variable extension of MediaWiki to gather this as you go along and add it to a certain variable string and then add it to the end.
Then I understand.
So it's, again, it needs some technical expertise to do this, but the templates I showed you certainly also. Okay. Okay, so that's, let me see, what time remains? None. 10 more minutes.
Yeah.
Thank you. So crazy queries, that's the other thing. If it's not your PHP, it's probably your database, and this might be the main reason for it. SMW queries have 3 stages really. Page selection, this is the actual query string. Data selection, which is adding these question mark printout parameters. And then formatting. This local formatting issue I discussed in the last section is mainly a combination of the second and the third. You have a lot of printouts which fetch data from one known source, and you do complex formatting. And you basically, in the solution, I suggested you replace it with one printout which already has the full format and doesn't need anything to happen anymore. But it can also be that the first step is slow. That the page selection, the ask query as such, is a slow process. And this you would normally see in a slow query log. Unless the slow query log comes because your server is so much under stress from other reasons. But normally you could identify it from that. So what to do? Well, let me give you an example. You have annotations which say a bus line has the property stops at bus stops. So you have pages for bus lines and pages for bus stops. And you say on all the bus line pages where the line stops at, and you say on all the stop pages which line the stop is served by. Two-way indexing. I mean, with inverse properties, I actually don't need both ways. I figure it's even enough to have one. But let's keep it like that. And now you can have a query like this, served by stops at some bus stop. So some bus stop is some bus stop. And this query gives you all the things, all the stops, which are served by something which stops at this bus stop. So it gives you all the stops which are on a line from which you can also go to bus stop. In other words, it gives you all the bus stops which have a direct connection to some bus stop, which is nice. You can also change in the middle, of course. You can say you want all bus stops which are served by a line that stops somewhere where you have another line which stops at some bus stop. So I want to get to some bus stop with at most one change. Where can I stop? And you can, of course, extend that. And this is very interesting. Solving a pathfinding task in Semantic MediaWiki, but in a very, very dull and exploratory way. I mean, pathfinding wouldn't be too hard. There are at most linearly many bus stops, of course, but the number of possible routes by going onto a bus line, getting off again, taking the same line back to the original point, stuff like that is, of course, exponential. So you can easily get millions of possible results, which are then filtered with distinct to get only the bus stops where you can come from. This is a real query, which was one of the first crazy queries we found on one of our wikis, which triggered us to change some of the settings on that side. Because I mean, basically you can't solve that. No database application is going to be great on this type of task. I mean, it might be you could optimize for this a bit. It's a tree-shaped query, you could resolve it from the end, and yeah, there are optimization methods, but in the end, you can also always blow it up in some way. And this is certainly not a computation task that ask queries are meant to solve. Basically, there are 3 ways to prevent that. One, stop such madness early on. Just set the parameters in Semantic MediaWiki so it's not allowed, period. And do it as early as possible, because otherwise your users will complain that you disallow something which used to work. It's much better to disallow it right away. Aggressively cache query results, that's the concept thing, and then use a query engine that can possibly handle this, which might be an RDF store. I'm just going over the first 2. There are a lot of parameters in SMW to limit what queries are allowed. In particular, there's something called the maximum size and the maximum depth of a query. The depth is really how far can you go into the data model by chaining properties. What we saw with this served by stops at query is depth 2. When when you have 1 change, you have depth 4. When you have 10 changes, you have depth 20. Size is just the number of conditions in one query, whether deep or wide. And by setting these numbers lower, you will have simpler queries, period. And well, there's also something to control the query features. You could, for example, say, I don't want to have disjunctions because I somehow think they make the query slow. Or you want to make the limit much more restrictive that people are allowed to retrieve. So you don't want 500 results on the page, but only 50 at most. This could be done. You could also disallow similarity, string similarity as a comparator and stuff like that. It's basically all configurable, and people should make use of it if they really have these problems. Second thing, concept caching. Concepts are virtual categories. The idea being that instead of saying what is in the category, you specify a query which says what is in the category dynamically. That's why concepts seem to be an appropriate term, because it's like a concept of something. You could have a concept like 2011 conferences, and you could have a query which describes what a 2011 conference is, and then this is like a virtual category that shows all 2011 conferences. There's a concept namespace for it, and some syntax to look up online how to specify the query. It's not very difficult. And then the idea is that you can use these categories in queries just like categories. And the idea behind this, again, is that it would be possible to pre-compute the result, for example, to pre-compute what the 2011 conferences were, and just to use this list instead of executing the query at all places where this is used. So this can be useful, and there's a special maintenance script for building these kind of caches in advance, and also there are a lot of parameters to control which kind of things are allowed in concepts as opposed to in inline queries. And the rationale behind this is that you might want to say, well, in general, I don't trust my users, I want to have very small queries, very simple features only, but they are allowed to use much more features in concepts. But I will run the concept cache update script regularly, and if I find that some page doesn't cache because it's so slow, I can whatever, delete it or restrict my settings further. So it's a more restrictive, controlling way of updating caches happening here. There's no automatic caching. You have to decide yourself when you want to update the cache. But it can be configured so that it automatically discards the cache after some time has passed. So there are, again, similar parameters as before. And one interesting thing one could do here is make the size of normal queries very small, makes the size of concepts very big, and then this is the default anyway, set concept caching to the hard concepts, so the ones which are too hard to be executed in line. And this will advise Semantic MediaWiki to cache all the concepts which couldn't be computed in line. And this, then you just have to run the script and update all the hard concepts, and it's going to compute the right ones. So that's the idea. Okay, and then the third of the solutions for this crazy query issue would be to use some backend which is faster, and I hope maybe these are RDF stores. I'm going to talk about this tomorrow morning, so I'm not going to go into this now. The most important and powerful way to make Semantic MediaWiki faster at the very end, improve the software, right? And this is not just the joke at the end, but it's really a serious thing to do, to consider. If you have complex formatting, is it really a good idea to implement this format in a template? Why not just write these 50 lines of PHP to do the same thing, which can then be at least bytecode cached, and it is also much faster for things like string operations. And maybe it can also be shared, maybe other people want to do the same. So result formats are easy to implement in Semantic MediaWiki, and would be one simple example where you can really speed up your page construction and not have to be a very huge PHP expert to get results. Help needed in making SMW more efficient, yes. I mean, for example, I talked about object caching being a great thing. Unfortunately, SMW doesn't make use of it. We should, I guess. So maybe somebody wants to join in and help there. And also, extensions need to become more efficient. We already saw Semantic Drill Down today, which is a good example of an extension which really consumes a lot of performance to do some very nice things, but maybe we could make it more efficient to do these things. and still have the functionality. Okay, now we're waiting for the conclusion. I presented 0 plus 4 steps. Conclusion, it can be easy to do it. Give it a try. Spend at least half a day thinking about how your site could be faster. The users will like it, and if not, at least the environment is going to have some benefit from it. Thank you very much. Okay, and I will put this online so you will have all the links and can look up the details. I mean, there's a lot of manual going around there. Okay, I'm happy to take questions now or just offline while we're walking to the restaurant. Thank you.